The observable universe refers to the portion of the universe that we can observe and study using telescopes and other scientific instruments. However, our ability to observe is limited by the nature of light, which serves as the primary source of information about the cosmos. Light travels at a finite speed, which means that it takes time for it to reach us from distant objects. This creates a boundary on what we can observe, as we are only able to see objects and events within a certain distance. This boundary is often referred to as the observable universe, which doesn't mean it's the total size of the universe, but just the part we can currently detect with our technology. Moreover, this boundary is determined by the amount of time that light has had to travel since the universe began. Since we are observing light that has traveled from very distant objects, we're actually seeing those objects as they were in the past, not as they are now. The diameter of the observable universe is estimated to be about 93 billion light-years, which is considerably larger than the estimated age of the universe, 13.8 billion years. This discrepancy arises because the universe is expanding, causing objects to move away from each other. As a result, light from some of these objects takes longer to reach us. The universe is a vast and enigmatic space, and although we have gathered significant knowledge, there remains much that we have yet to discover. The James Webb Telescope, along with other advanced instruments, offers new opportunities to expand our understanding of the universe's structure, composition, and history. These tools allow us to delve deeper into cosmic phenomena that have remained mysterious for centuries, unveiling new layers of complexity in the cosmos. What lies beyond the observable universe is one of the most profound questions in cosmology. To explore the farthest reaches of the observable universe, we would require transportation methods that surpass current human technology. Concepts such as wormholes or distortion engines, which could theoretically allow us to bend space and time, have been proposed as possible solutions for such a task. However, these ideas are still hotly debated among scientists, many of whom argue that faster-than-light travel is impossible as it contradicts the laws of physics as we currently understand them. Despite these challenges, the idea of breaking the light-speed barrier remains a subject of fascination. Even if such technologies could one day become a reality, they would necessitate advancements in machinery and a deep understanding of the fabric of the universe, both of which are currently beyond human capabilities. The theory of cosmic inflation, which suggests that the universe expanded exponentially just after the Big Bang, proposes that the actual size of the universe is vastly larger than the observable part. In fact, it may be at least 10 to the power of 23 times larger than the region we can observe. This number is so enormous that it is almost impossible for the human mind to grasp. While we can only see a small part of the universe, scientists continue to speculate about what may lie beyond the observable limits. Theories about unobservable regions are built upon the data we have gathered from studying distant galaxies, and NASA plays a critical role in this effort. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Telescope became operational this year, NASA had already published images of the ultra-deep field obtained with the Hubble telescope. When the James Webb Telescope made its debut, it was used to observe the most distant galaxies ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos, apparently as they were millions of years after the Big Bang occurred approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. These data revealed the existence of a significant population of galaxies that were forming stars in the early stages of the universe. The discoveries are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we are alone in this vast universe. However, these new determinations within the observable universe lead us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Are there extraterrestrial beings somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system, known as exoplanets, which have been discovered using techniques such as the transit method and the radial method. Some of these exoplanets may have Earth-like characteristics and harbor life. This theory has been supported by another discovery made thanks to the James Webb Telescope, related to the exoplanet WASP 96b. This planet is located outside our solar system, and its light spectrum reveals something surprising: the presence of water molecules. In addition, the spectrum also shows signs of haze and clouds, which were not previously thought to exist on a habitable planet. Based on habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. The multiverse is mainly discussed in the context of quantum physics, which deals with the behavior of tiny particles, such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative and is not yet supported by conclusive evidence. Therefore, it is difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrödinger's cat thought experiment or the nature of dark flow. It is a concept that arouses fascination and reflection but requires further research and evidence to be confirmed. Thus, the phenomenon known as dark flow exists. The question is complex and raises an intriguing issue. Dark flow emerged in 2008 as a possible explanation for the observation that some galaxy clusters appear to move faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy that pulls them in a specific direction. However, the existence of dark flow remains controversial and has not been accepted by the scientific community at large. Some studies have suggested that dark flow may be real and could be caused by the presence of a massive structure in a universe that exerts an attraction on galaxy clusters. However, other studies have failed to confirm the existence of dark flow and have proposed that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected galaxies. While some studies suggest its possible existence, we cannot state with certainty its presence outside the observable universe. More research and evidence are needed to better understand this intriguing phenomenon. What do you think? Let us know in the comments box. Remember to like and subscribe. Thank you so much for watching. See you soon.